Satellites are everywhere, beaming down GPS signals, enabling weather forecasts, and even connecting us through the internet. But have you ever wondered, how do satellites stay in orbit? What keeps them from falling back to Earth or flying off into space? Welcome to my channel, everyone. In this video, I will explain the science behind satellite orbits, using real, provable facts to show why satellites work the way they do. Let's start by answering this fascinating question. To understand how satellites stay in orbit, we first need to know what an orbit is. An orbit is the curved path an object takes around a planet, star, or other massive body due to gravity. Isaac Newton explained it best. Imagine firing a cannonball from the top of a mountain. If you fire it fast enough, the cannonball will fall toward Earth due to gravity. But because Earth is round, it keeps missing the ground and continues traveling in a curved path. That's an orbit. Satellites work the same way, except they're launched at incredibly high speeds to ensure they stay in orbit instead of falling back to Earth. The key to staying in orbit is gravity. Earth's gravity pulls satellites toward the planet just as it pulls everything else. Without gravity, satellites would simply drift off into space. But here's the trick. Satellites are launched at such high speeds, about 28,000 kilometers per hour, 17,500 miles per hour for low Earth orbit, that their forward motion balances the pull of gravity. This balance creates a stable path around Earth. The satellite is essentially falling toward Earth, but its high speed keeps it moving forward so it stays in orbit instead of crashing. Speed is everything when it comes to satellite orbits. If a satellite isn't moving fast enough, gravity will pull it back to Earth, causing it to burn up in the atmosphere. On the other hand, if it moves too fast, it will escape Earth's gravity altogether and fly off into space. That's why satellites are launched at very specific speeds, fast enough to counteract gravity but not so fast that they leave Earth's orbit. The exact speed depends on the type of orbit. For example, satellites in low Earth orbit, like the International Space Station, travel at about 28,000 kilometers per hour. Higher orbits, like geostationary orbit, require slightly lower speeds because gravity is weaker farther from Earth. Not all satellites follow the same path. There are different types of orbits, each designed for specific purposes. Low Earth orbit. These are the closest orbits, just a few hundred kilometers above Earth. Satellites in low Earth orbit, like the Hubble Space Telescope, provide high-resolution images and quick communication. Geostationary orbit. This orbit is about 35,786 kilometers above the equator. Satellites here move at the same speed as Earth's rotation, meaning they stay fixed over one spot. These are perfect for weather and communication satellites. Polar orbit. These satellites pass over Earth's poles, allowing them to scan the entire planet as Earth rotates. They're often used for environmental monitoring and mapping. Each orbit has specific speed and altitude requirements to ensure the satellite stays stable. So, how do satellites avoid falling or flying away? The answer lies in the perfect balance between two forces, gravity and momentum. Gravity pulls the satellite toward Earth, while inertia, or momentum, tries to move it in a straight line. When these two forces are balanced, the satellite achieves a stable orbit. It's like swinging a ball on a string. Gravity is the string, and the satellite's momentum keeps it moving in a circular path. If the string breaks, meaning gravity weakens, the ball would fly off. Satellites don't stay in orbit forever. Over time, atmospheric drag, even at high altitudes, slows them down, causing them to lose energy and fall back to Earth. Low Earth orbit satellites typically last a few years before burning up during re-entry. Geostationary satellites, however, can last for decades because they're much farther from Earth's atmosphere. When their mission ends, they're often moved to a graveyard orbit to free up space. And that's how satellites stay in orbit, by balancing speed, gravity, and momentum. They're marvels of engineering that have revolutionized the way we live and explore the universe. What part of satellite technology surprised you the most? Let me know in the comments below. And don't forget to like, subscribe, and hit the bell icon for more fascinating science content. Thanks for watching. I will see you in the next one.